Hey everyone, continuing the general techniques for integration, we'll start with something simple, and we have the general exponential rule. Okay, this rule is actually derived from the derivative of exponential, where we have the derivative of e power fx would be f prime and y, or f prime e fx. All right, if y equals to e fx, then it'll be f prime y, but it's the same. So if you have the integral of an exponential, the first form that you really want to look out for is whether if there is a f prime x e fx form, so that if you can just directly integrate this to e fx plus c. Okay, so let's look at a few examples and apply this rule. So firstly, something simple, algebra, x times e power of x squared dx. Okay, so we look at this form, right? So first of all, you're actually going to look with respect to exponential, because that's integrate with respect to exponential, because exponential is easiest to integrate. So we notice that the power is x squared. The derivative is simply 2x. And we have the derivative x multiplied to ex squared. We just basically get 2. So we just do divide by 2 in our final answer, and we get ex squared over 2 plus c. Same thing if we have, for example, cosine x e power of sine x dx. So we notice, well, if this is my power, which is fx, then my derivative is cosine x, which is right here. Therefore, the integral is simply e power of sine x plus c. I can even expand this to, let's say, 3 over x e ln x dx. So again, I focus on the power on the exponential. So I label this fx. The derivative of ln x is simply 1 over x. Therefore, my integral is simply e power ln x, because it's a constant 3 plus c. Alright, so as you can tell, it's rather simple, alright, for the general exponential rule. And I'm going to show you that you can even use this rule in your integration by parts. For example, we have x cubed e power of x squared. Alright. So clearly there's no directly integrable form, right? Because the derivative of ex squared is 2x ex squared, but you have x cubed multiplied to the ex squared, so that's definitely not an integrable form. The derivative of x cubed is not ex squared, so we can forget about setting x as and using the general power rule. So what else can we do? Can we use substitution? Well, no, because 1, you're not given the substitution. 2, I don't think there's any substitution, because once an algebraic function and their term is an exponential function, it's quite hard to find a substitution that nets you a directly integrable form, so we can forget about that. So what is left? Well, integration by parts, right? But in integration by parts, you have to find one term to integrate first before you can differentiate the other function, because integration by parts is integrate one and then differentiate the other. So you look at this integral. What can you integrate first, right? If you're going to integrate x cubed first, so let's, for example, we're going to integrate x cubed first, you're going to get x4 over 4 and ex squared. And you differentiate ex squared, you get x5, and you realize it's getting higher and higher. The power is just going to get, keeps increasing. So definitely not an option to integrate x cubed first. As such, you have to kind of integrate ex squared first, right? So if you integrate ex squared first, we need to have the x with it, right? Because you cannot just integrate ex squared directly. You have to integrate it as part of x ex squared. As such, let's look at it this way. We write it as x squared times x e power of x squared dx first. You notice you can integrate this whole term first. Technically, there's 3 products here, but it's actually changed to 2, right? X squared times x e x squared. And you notice that, well, if I integrate x e x squared, I'll get back ex squared over 2, right? Then I minus sign, I apply the integration by parts, and I differentiate 2x to give me, integrate x squared to give me 2x, and I'll get ex squared over x ex squared. And then you notice, hey, I can integrate x ex squared, right? Because, well, this is the powers, the fx. The derivative is simply 2x. I'm just missing the 2, but I have the x, which is sufficient enough. Then I'll get the final answer of x squared ex squared over 2 minus ex squared over 2 plus c. Alright, so this is also how general exponential rule can be used in your integration by parts, and that it also lets you know that even in integration by parts, you're not just limited to integrate term by like each term separately, right? Because some of you might notice that, oh, I can either integrate x cubed or ex squared, but you know, I can actually integrate as x squared and ex squared instead. It really depends on the context and the integral. All right, so there we have it, the general exponential rule.